where you're joining us from. I'm calling in from the great Northwest in Seattle, Washington in the U.S., and I want to welcome you to the latest Engineering for Change webinar. Engineering for Change, or E4C as those of us who call it, has been running this webinar series this year. Today's webinar is a preview of some of the presentations that will be delivered at the IEEE Global Humanitarian Technology Conference, or GHTC as we call it, and features speakers Jim Fruchterman, Justina Su, and Alex Grainer. My name is Paul Kostek, and I'll be moderating today's webinar, and I'm also the chair of this year's conference. So a little bit about the series and about today's webinar. Today we're talking about open source software, opportunities for social innovation from around the world. And this is a topical focus area into info systems, and we're glad to have the opportunity to address some of these important issues related to this field today. And as I've mentioned already, we've invited some presenters who will be speaking at GHTC, and are experts doing work around the world on this. And I want to thank Jim, Justina, and Alex for joining us today. Before we get rolling, I'd also like to take a moment to recognize the folks who bring all this together, the coordinators for E4C. And for those who aren't familiar, E4C is actually a joint effort of several engineering organizations. Iana Aranda of ASME, the mechanical engineers, and Holly Snyder-Brown and Alex Torres of IEEE do the work to develop and deliver this webinar series, and we thank them, the team, for the work they do on this. If anybody has any questions about the webinar series or maybe some suggestions, on the slide you have in front of you right now, there's a contact email about webinars at Engineering for Change. Please send an email there, and the team will get back to you on opportunities. All right, a little bit about Engineering for Change. It is an organization that, as I said, is composed of multiple engineering organizations. There's about 11,000 individuals that joined. This is a no-cost membership to join E4C, and it brings together engineers, technologists, NGOs, social scientists, all those people who are working together on critical humanitarian challenges. And topics they address are water, energy, health, agriculture, sanitation, and we're always looking for new areas to consider. So if you have some ideas, you may want to consider joining E4C and also contribute your ideas and suggestions. Besides IEEE, ASME, the Civil Engineers, Society of Women Engineers, Engineers Without Borders USA, and ASHRAE, plus numerous academic supporters like MIT's D-Lab. And we also have international development agencies like USAID and Practical Action are part of the community that's working many of these issues. Encourage you to check out the website. It's right there at the bottom of the slide. That's a great way to learn more about Engineering for Change and the things that you can do. So the webinar series itself, just a little bit of background. This is the latest installment of these webinars that are being offered. They're all offered free. They're online seminars, and they showcase the best practices and thinking of leaders in the field who bring leading-edge technology and solutions to bear on humanitarian and development challenges. And there's information on upcoming installments in the series, as well as archived videos of past presentations, again, can be found on the website. And you can also check out E4C's YouTube channel. Just a little bit of a preview. The next webinar will be on October 18th. This one's going to be Releasing Trapped Knowledge in the WASH Sector, Empowering Residents to Implement Solutions, with Mina Palapan and John Cudato from the Pacific Institute. And again, to register, there's a link there that you can go to register for that opportunity. Just some housekeeping rules for today. You can look in the chat window. We wanted to get an idea of where people are from. So if you could, in the chat window, type in your location. Also, if you have any technical questions or admin problems during the presentation, you can also go to the chat window and send a private message to either Holly or Yana to help you out. And if you have any questions, or you can type those in there. We'll be dealing with questions at the end of the presentation. And if necessary, at the end of the webinar, you can request a certificate of completion showing 1 professional development hour for this session. So you'll just need to provide your full name and date you completed this webinar, as well as the code that we'll give you at the end of the session. And you can send this to eab-ceuadmin@ieee.org. All right. As we get started, I wanted to just give, for those who aren't familiar, a quick intro to the Global Humanitarian Technology Conference. The conference is coming up in about a month here in Seattle. This will be the second conference. The first one was held last year, also in Seattle. It's a conference that was actually created by both the Seattle section of IEEE and Region 6 of IEEE, coming together to deal with the issues that IEEE as an organization had been doing in humanitarian activities, but there really hadn't been a gathering spot where people could come in and talk about projects that were going on, talk about how the engineering community can play a role in advancing humanity with technology, and at the same time bringing in people from NGOs, government agencies, academia, industry to kind of talk about what are the most realistic solutions that we can come up with. We have a great list of speakers this year. As you can see, you'll be hearing kind of a preview. Jim Fruchterman, who's one of our keynote speakers. Jim actually is going to have the big job at the conference. He's going to be our closing keynote speaker on Wednesday. He's really going to be the kind of the person bringing all of this together. But you can see we have a wide range of sessions that we will be addressing topics. We also have the conference set up so there's actually a track that's kind of wide open for people to actually gather together as they talk at the conference and say, you know, there's some sessions or there's some topics that haven't been addressed, and here's a great time for us to kind of come together and talk about these. So hopefully people, if they have time, will be able to get up to Seattle. And I can give a little early preview that in 2013, the conference is actually going to be headed to the Bay Area. We haven't picked the exact location yet, but the planning will be in the Bay Area in 2013. Registration is open for those who are interested. And what you have in front of you is the wide-ranging groups that are financial supporters, that are helping us with publicity, that are our exhibitors, also speakers and presenters. So we've tried to, as much as possible, bring together as many different people from as wide a scope as possible to provide you, the attendees, with as much opportunity to learn about what's going on, find ways to participate, whether it's actually in the field or developing technologies, and really just kind of bring a huge community together of people to develop a long-term plan as to how do we help growth, not just in the developing world, but even in the developed world in areas that are still remote from major technologies. With that, I am going to turn it over to our presenters. You see them in front of you. And first up is Jim Fruchterman. And then I won't take time to read Jim's bio. It's in front of you. He has gone from both the profit world to the non-profit world, which I think is a great story. And his company now is moving in this initiative with the software area. So with that, I'm going to turn it over to Jim.
Thank you very much, Paul. Really appreciate that. So I'm going to talk today about social change at scale. I believe that technology has built into it the ability to go to great scale. And of course, in Silicon Valley, people use that scalability to generate great wealth. But I think that same power can be used to actually advance social objectives even when they don't make someone a lot of money. So I'm a geek, and I'm proud of it. And I think like a lot of geeks, we love technology, we love solving problems, we love figuring things out, and we love thinking about what technology can do. And, you know, my original objective as a geek is that I wanted to become a scientist astronaut. And I was in a electrical engineering PhD program, and we ran an entrepreneurship talk series, and the second speaker was the president of a private rocket company. And so this was kind of irresistible. He offered me a job. I took a leave of absence from my PhD program and became the chief electrical engineer for a private rocket company in my early 20s. And let's just say it wasn't NASA class. Anyway, to cut a long story short, the rocket is on the launch pad on the Gulf Coast of Texas. Our business manager, who's from Texas, is doing the countdown. So it's, 5, 4, 3, 2, 1. Oh, sheep! Bleep. Suddenly, something happened to the rocket. It blew up. And that was the end of my rocket engineer, rocket scientist career. Oh, by the way, it wasn't an electrical problem. It was an aeroastro problem that caused it to blow up. But anyway, I came back to Silicon Valley, and with the guy who had been my boss on the rocket project, we decided to start an optical character recognition company. When I had been in school, I'd been learning how to make guidance systems for smart missiles using pattern recognition, and instead of recognizing tanks in the battlefield, recognizing letters and words on the page was a pretty cool technical application. And from the very beginning, from the time I was in school, when I thought about this, I thought, well, you could be actually helping blind people to read. So to make another very long story short, we actually built a prototype of this reading machine, and we showed it to our venture capital investors. And they, saw the demo. We scanned a page. We read it aloud with a first-generation voice synthesizer that was very artificial sounding. And right after the demo went well, the board asked me, well, what's the market size for reading machines for the blind? And I said, well, we've done some research, and Ray Kurzweil's invented a reading machine, and we think they're selling about $1 million per year. This did not go over very well with my investors, and they basically said, what's the connection between this reading machine for the blind product, this new product that you want to do in addition to the ones that you're making that actually make us money, what's the connection between that and our $25 million investment? Well, that's really the kind of question that I've been trying to answer with Benetech for the last 25 years. So many great applications of technology don't make boatloads of money. And as an engineer, I was very proud of our invention, and I was really interested in seeing that it did what I thought was the most important application, which was helping blind people, as opposed to helping save the Internal Revenue Service or an insurance company or a law firm money in scanning in documents. So we actually built this reading machine product, the Arkansas reading machine product, and we created a non-profit technology company. So our goal was actually to break even as opposed to make a lot of money. And it became a profitable $5 million a year company within a couple of years, and we sold over 40,000 reading systems to blind people, to severely dyslexic people, and the like. And so we actually had found a way to deliver this product, not delivering venture returns, but delivering actual social good. We sold that reading machine for the blind business to a for-profit company and got $5 million in 2000, basically when the dot-com bubble popped just before that happened. And we used that money to create new social ventures under basically the Benetech umbrella. And the first one of those was actually helping blind people, but in a new way. Rather than making reading machines where they could scan their own books, use sort of the Napster model to allow them to scan one book and share it with everybody else that's similarly situated. And one of the great benefits of this is that it's much cheaper to deliver an e-book than deliver or create a human-narrated book or a physical print book or a book on audio cassette tape. And so Bookshare is now 10 years old. We deliver a book to a blind student like Curtis for 1/15 the price of the traditional human sort of oriented ways of delivering accessible books. And we're serving more than 200,000 students. And of course, we surround this with a bunch of open source technology, for example on Android, that makes it possible to read these books, or open source technology that makes it easy to add, let's say, math and science descriptions to pictures in textbooks so that students with disabilities can have a shot at technical careers. But that's not the only thing that we decided to do at Benetech. We also decided to tackle the human rights field. And our kind of question was, what can Silicon Valley do to help the human rights movement? And if you sit back and think about human rights, it's basically an information processing industry that nobody actually writes software for or makes products for because they can't make enough money. So we developed a series of open source tools designed to help collect human rights information, actually, when we have a lot of it, analyze it, do statistics, basically try to bring the power of technology that would benefit any other industry, but bring it to the human rights field and help them be more effective, because the story of human rights is basically an asymmetric battle between the advocates for human rights and the people who are essentially committing human rights abuses. So I'm going to give you one example of this kind of a project. This is a picture of the Guatemala Police Archive, the National Police Archive. It was thought to have been lost. 60 to 80 million pages of human rights documentation. The Guatemalan government called us because of our expertise in this field, and they said, what do we do with this? And we say, well, that sounds like a medium-sized asbestos litigation. So we helped them come up with a sampling plan, scanning the documents. After we'd scanned more than 10 million of the documents, which are online and freely available to everybody, we actually searched for certain cases, found 400 documents about a very famous disappearance, and the 2 police officers who actually disappeared this guy more than 20 years ago, he was a labor organizer, actually got convicted of the disappearance. And right now, the former head of Guatemala's sort of national secret police is actually on trial for a campaign of urban disappearances. So we're not a human rights group. We're the geeks that make the human rights movement more powerful. And our chief geek is Dr. Patrick Ball, the world's leading human rights statistician. And what Patrick does is he tries to basically shine the truth on these things. He's been the expert witness against Slobodan Milosevic in his war crimes trial. He's going to be an expert witness in the genocide trial of Guatemala's former dictator. Has worked on more than 9 truth commissions. And so, but it's all about helping people come to grips with the data. Now, the Benetech model actually is applicable many different places. And I'll share with you that every week someone asks us to build a technology product, not to do consulting, but a product that isn't going to get built by the traditional for-profit world because the market size is, $500,000 a year or $2 million a year, things that are way below the interest level of venture capitalists and angel capitalists. So a couple of years ago, some of the major environmental groups came to us and said, hey, we heard you wrote software for field people in the human rights movement. Do you think that you can actually write software for environmentalists? So now Benetech has the leading, probably the only, software for open source management of environmental projects. So whether you're running a wetlands restoration, trying to analyze biodiversity in the jungle, run a campaign to convince your community to actually change its behavior, there's now a project management package that actually helps guide you through step by step what you need to do to actually have a successful project. We kind of call it TurboTax for the environmental activist. And if you look under the hood, the science and technology, the business rules, are all the same thing that you'd have in any project management package, except for if we gave these environmental activists Microsoft project, they'd probably commit suicide. So our goal, just like there are 50 software packages for managing construction management, let's give the people who work in the environment a tool that helps them actually manage projects in terminology and sort of the special things about environmental projects that they understand best. And if we can do that, as engineers, we'll have helped advance, the spending of billions of dollars of environmental sort of project money. What if we made that 10% more efficient? Well, compare that to the few $1 million that were invested in the software package. The impact, the leverage is incredible. But we're used to that in the technology field. In the nonprofit sector, it doesn't happen so often. So one of our new projects is actually social coding for good. And if you actually go to socialcodingforgood.org, you'll see it. This is one of the projects that came through our annual new project competition. We basically take the 50 or 100 ideas we get and we pick which one can we turn into a social enterprise. And our preference is always for open source, and if it's content, open content. Our goal as a nonprofit is not to make money, it's to figure out how to do the most social good while breaking even, while finding the money to pay our technology staff and pay our marketing people and our tech support people. We're a 75-person high-tech company that looks a lot like a regular software company, except for we have 7 or 8 software projects, and our goal is to do maximum social good. But because we kept getting asked to do all these projects that we couldn't do, we realized that there was a lot of need for a lot more technologists to put to bear on this. And this, of course, is the same thing that's behind Engineers Without Borders or Engineering for Change. I mean, I think there's this immense demand in the technology community to see our technology skills, the things that we've learned through our profession, actually apply to society's biggest issues. So what's Social Coding for Good? Think of it as an online dating site for open source software professionals that want to volunteer on social good open source projects. So it's all about matchmaking. It's tell us your technology skills, tell us your passion, what kind of issue do you care about, tell us about your time availability, and we'll connect you up with the project that actually needs your benefit. It basically needs your skills. And so this is in a pilot form. And on the supply side, we work with high-tech companies. VMware and Hewlett-Packard are just a couple of the companies where we're actually working. And on the demand side, basically the projects that need open source developers include projects like Frontline SMS or Wikimedia or Code for America or even Mozilla, which is probably one of the big open source projects. But we all need, as open source foundations, we all need a better supply of professionals who are interested in our issue and have the skills that we actually need. And so by making this matchmaking happen and helping people actually get into the sector, we're going to make a bigger impact. We've also tackled, I think, the hackathon challenge, and we've become a partner with Random Hacks of Kindness, one of the coolest names for a hackathon project I can imagine. But basically, we're going to bring them projects that are actually things that if you develop this open source module, it'll get used. We did a partnership with Random Hacks of Kindness a couple months ago. Our challenge is actually sifting math equations away from pictures of math and making math books accessible. And we got a tool that actually 95% accurate in classifying things as equations, which we'll route through a specialized process to turn into math markup language, and pictures, which will go to a technologically skilled human to actually do that. And of course, we got that module. It's going to be added into our open source Poet tool in the next month, and it'll be available to teachers and basically Braille transcribers to make accessible. So I think this gives you a flavor of the range of opportunities, and I think the fact that you're here and part of this conversation is because you're interested in this. And whether you're a software engineer, a systems person, a person who's good at human interface design, whether you're a hardware engineer, the world is full of things where the technology already exists, the social need exists, but our Silicon Valley system is incredibly good, or whatever sort of technology is incredibly good at focusing on the needs of the top 5 or 10% of humanity, and not the other 90%. And because these are fundamentally intellectual property issues, where the marginal cost of actually putting something into use is actually quite low, we can actually make giant impact on actually advancing all of humanity. And I'm just really excited about the possibilities, and I hope that many of the people on this call, think about something that they're passionate about and find a way to actually use their technology skills to actually see that all of humanity benefits from the technology and science that we've created as a profession. Thanks a lot.
All right, thanks much, Jim. Appreciate that. With that, we are going to move on to Justina Su. Justina?
Yes. Okay. Good morning, everyone. Thank you for having me. I'm really impressed by Jim's account about what technology and open source software can do. My name is Justina Su. I'm currently working at Fugong University in Taiwan. Today I'm very happy to do a brief introduction about the paper that I'm going to present at GHTC. My topic is the emergence of free and open source software on campuses in Taiwan. My paper looks at the historical aspect of the diffusion of force at school in Taiwan. Okay. Well, let me do a brief summary of my paper. In 2003, the Taiwanese government set up open source software application consulting center to promote force on campuses. In these 10 years, force on campuses has begun to find its local meanings and grasp teachers' and students' attention. The purpose of this paper is to investigate force in terms of its development, its local significances, and the difficulties encountered in promotion, in the hope of providing an understanding and interpretation of force in the context of education. The result indicates that the majority of teachers and students do not recognize or identify with the cultural values embedded in force, but use it as a tool to solve educational problems. As we may know about force, it is a technical artifact full of social meaning, as it confers most of its rights to users. Free software has a strong educational appeal because it can be used freely in an educational context for technology integration and for computer literacy without either teachers or students worrying about the legal issues surrounding software. Moreover, due to the fact that free software comes with open source, schools can customize it to meet their needs. Therefore, it is an option that can be promoted in campus. However, introducing free software into the educational context has its complexities. Let me talk a little bit about the origin of force promotion in Taiwan. In 1984, the Ministry of Education announced a tentative clause to regulate the standards and equipment of computer education in schools at all levels. At that time, force was not particularly promoted. It was not until 2002 that National Information and Communication Initiative Committee in Executive Yuan set up a free software guiding committee to promote its use. Consequently, part of the budget went to the Ministry of Education to support the diffusion of force. The conscious bottom-up school endeavor for force promotion have to do with the Special 301. The anti-piracy campaign had a great impact on school, as most of them were not equipped with enough software licenses. But in the year of 2004, many local governments signed a software campus agreement with Microsoft. As the use of proprietary software becomes legal, a lot of schools give up Linux and install only proprietary software instead. Well, let me talk a little bit about the government attitude. The government is one of the major supporters for force promotion. Every year, the Taiwanese government invests about 150,000 US dollars on promotion of force in Taiwan. The reason has more to do with counterbalancing the development of proprietary software than to do with agreeing with its ideology. In other words, the government has a strategic consideration for force. The support was to create a threatening situation for commercial software. Therefore, in the educational context, force is used as a bargaining chip in the negotiation with proprietary software companies. Okay, and OSAC is a project commissioned by the government and plays a key role in the promotion of force at school. However, the government support for OSAC is not continuous. Since 2003, there have been several gaps between funding periods, and some even span over several months. Okay. Every year, OSAC issue a Linux distribution for school use called EasyGo. One of the most acclaimed feature of EasyGo is the easy-to-use menu, as you can see from the slide. The name of the category is attached to the beginning of the application. So as you can see here. Okay. In 2011, the ninth version of EasyGo included more than 130 applications. In the category of education, there are subcategories such as programming, math, and chemistry. All of the software titles are about 100% translated into traditional Chinese for school use. Okay. The cultural meaning of force on campuses in Taiwan is kind of being reduced to being free of charge and law abiding. Since the enforcement of the anti-piracy campaign on May 1st, 2002, the major discourse surrounding the use of force has been to assist schools in solving problems with software licenses and to keep the service of information technology running. In 2007, the government initiated a citizen computer plan for economically disadvantaged students. Both operating system and application were installed on these computers. In this case, force is used to maintain the equal opportunity of school children. To sum up, force is perceived as being free of charge, law-abiding, and protecting students' learning rights, and is regarded to be a tool to solve educational problems. However, instead of identifying themselves with hackers, culture, or being part of hacker communities, educational users regard force as a free gift, which make force culture rather barren in Taiwan. Okay. Many studies are conducted to analyze the difficulty of force promotion in Taiwan. The summary of difficulties can be divided into two types, use difficulties and culture difficulties. In terms of use, there are difficulties such as familiarity with force, a need for force relevance to teachers' expectations and work, and need for integration with hardware. And in terms of culture, there are difficulties such as difficulties in conveying the force spirit of participation and sharing, and government promoting force from the for-profit viewpoint, and lack of social identification with free culture. Okay. In order to increase the adoption rate of force, I think efforts can be made, such as increasing the participation of various social groups, providing a low-cost IT infrastructure, and supporting force from a non-profit viewpoint. The last but not the least, incorporating the cultural significances of force into the introduction of software. Okay, and this is my brief introduction, and thank you very much for your attention. Thank you.
Thank you very much, Justina. And with that, we will move to Alex Gaynor. And Alex is going to talk about some of the work he did at the university and before he moved on to his new gig at Google. So Alex, it's over to you.
Well, I'm sure we can avoid taking a tea break. For now, I'd like to talk about an application I made while I was at UT Santa Cruz, and it was based gathering healthcare data in developing countries, namely Africa. So I'm speaking on behalf of an organization called Health Records for Everyone, which was started by Phil Strong in 2008. It was started by running health assessment clinics in rural Africa in schools, and it was partnered with Project Mercy. And they began collecting patient data on paper records, and per year they would collect around 1,000 records, and you can imagine eventually it became very unwieldy trying to keep track of who they'd seen, especially in the coming years. They could have, say, 4,000 pieces of paper to look through to identify a single patient. So Phil suggested that they come up with a better way to record patient data without having to use paper, and so he suggested that they move over to electronic records. Now, in 1996 in the U.S., there was HIPAA, which called for the standardization of electronic health records, and out of that came a huge need for data interchange, and from that arose an organization called Health Level 7, and what they did was they created a standard called the Clinical Document Architecture, and this was based around data interchange, XML-based, and it also served for the basis for the Continuity of Care document, which is a subset of the Clinical Document Architecture. So this was kind of what we wanted to do. We wanted to take this standardization and apply it to rural areas in Africa, and so we could get a timeline for patient care and be able to exchange this data electronically if we needed to. So, as I said, the goal was to collect and maintain or retain patient data and produce patient records in this CCD format, so we would have standardized patient records, and therefore we would have more notions of continued care, meaning we could formulate a timeline for patient history. So the challenges that were presented to us were kind of interesting. We were set up in rural areas of Africa. We started in Yerevan, Ethiopia, and we didn't have any constant power to any electronic devices. We had a few generators, but we could only run those a couple times a day, so we had to rely on devices that had long battery life. And there was also no notion of connectivity. We couldn't set up a wireless network anywhere to connect the devices, so we had to kind of think out of the box on that one. There was limited technical support, so there was only one person over there who had any programming experience, so any software we would have to make would have to be very usable, very easy to understand. So out of that, our last challenge was facing clinic workflow dependencies. And by clinic, I mean when they go over to these areas, they set up a medical clinic, and it's usually either a set of tents or in some hospital made from bricks. And they have various stations where they administer certain kinds of care to different patients. So here's an interesting diagram of the clinic. So you have an intake station, and then you have various intermediate stations, and then you have an exit station. So the intake station, you take various demographic information, and then you push them through the pipeline until they're done with their visit and they go out. And so the software that we created was really modeled around this workflow, and we tried to avoid any bottlenecks in this workflow, but as you'll see later, we encountered a few bottlenecks. So the software is forms-based, and it started as a class project in 2011 at UC Santa Cruz and ended up being written in C#. And that became kind of, it wasn't very helpful for us, so we decided to refactor it during the summer of 2011. And so I was assigned with that task and built it using Django, which is a web development framework, and we posted on GitHub under the I come back. So having notion of networking. kind of the architecture of the application. It follows the model template view provided by Django. And so if you notice, our model is the CCD documents, CSV files, patient pickles, and we're saving and loading them from different stations, and then eventually, when a patient gets to this record, and that's where their standardized electronic health record is. Okay. So as I said, it's station-based, so when you start the application, you start up on the setup page, and you click which station you want to be for your intake demographic information. And that machine will serve as the intake station for the rest of the day. And then this is kind of the UI layout we have. So if you choose an intake station, as I said, you'll be doing demographic and nutrition information, and you can record that data there. And then once you reach the exit station, you'll save the record and you'll produce a CCD. So I also wanted to provide, can you hear me? Yeah. So we wanted to provide configurability and configure what options would be allowed for each station. So for example, some stations require in which users have so learn and what were results. So evidence of the software assumption 1,000 ability to create customized. If we saw a patient 1 year ago, now we can look them up this year if we run the clinic again. Okay. The goal here was to provide best practice features. So we learned a few lessons in terms of workflow. We had some bottlenecks in our station workflow, meaning that in the exit station, we used third-party software to produce standardized records, these CCD documents, and it ended up taking a very long time. We were trying to run it on the JVM while running Python, so we would have to boot up our Java virtual machine every time we wanted to produce a standardized record. So with that, we had some severe bottlenecks in our workflow, so we wanted to account for that in the next time we go through. And we also wanted to make the ability to create your own forms. In this case, if you're a clinic and you want to start your own medical clinic in some third world country, maybe not in Yerevan, but maybe in Haiti or some similar area for disasters, then you could use this application, create your own forms, and then have it produced out as standardized health record that follows that CDA or CCD documentation. So, future work for 2012, we would like to, as I said, allow medical clinics to fully configure web forms, which means there's no more programmer. Programmers can be expensive, and in my case that wasn't very expensive, but you know, we did some cost-benefit analysis on how much it would cost to pay a programmer versus have a scribe take all of the records and put it into an electronic medium. And we decided that it's about the same. So we wanted to actually move away from both and just give the ability to create forms to whatever medical practitioner was running the clinic. We also wanted to move away from the continued care document. The subset was beneficial, but it wasn't robust enough, so we would like to move to the full clinical document architecture, which is that standardization put out by HL7. And then we wanted to provide patient lookup in this application. So that is, if we see a patient again, we want to know that we've seen them before, so we need to provide that in the application, which does not support that just yet. And then we're going to run the new application again in October, and hopefully by then we'll have created a patient timeline and be able to improve our healthcare tactics. So that's it. So if there are any questions, please let me know. And if you are interested in seeing the source code, it's
much, Alex. And with that, it is now time to open up to the audience for Q&A. So if there's any questions, you can put them in the chat box. And if you have a particular presenter you would like to ask a question, you send it directly to, you just mention their name in the notes. So with that, it's open up to the audience now for any questions. So I've got one here that's just popped up. Looks like it's, and I don't know if all the presenters are seeing this or not, but the question is, I'm very interested in comments on how each project addressed security, privacy, and reliability concerns. So why don't we just start at the beginning and work through? So we'll start with you, Jim.
Yeah, so security has issues around every single one of our projects. So for example, when we operate a library for people with print disabilities, we're covered by not only our own privacy policy, but also we have basically a law called FERPA, which is around the confidentiality of privacy records. And so I think that's the something that we have to do. And basically, we have to use sort of, I think, standard security practices. For example, you can't log in to our database from the internet directly. You have to actually either be inside our facility or get there through a VPN sort of setup. And I think we kind of look at what best practices are in our field. Now, in our human rights software, sort of security issues are much bigger. We're talking about human rights activists that are collecting human rights data in places where the government is often perpetrating human rights violations, where the government has co-opted the internet service providers. And so at the core of our MARTIS software for collecting human rights data is something called, basically it's public-private key crypto. So basically all the content is done through essentially cryptography, and we've done a lot of work to make sure that the cryptography is actually usable by a mere mortal, but also is proof against the ability of the government to essentially read the content. Now, we end up having to warn our users, though, that it's still possible to see encrypted traffic in traffic analysis. So, for example, you wouldn't want to be sending encrypted packets to one of our servers from Tibet because the Chinese government has a great deal of capacity to track that. And we are currently negotiating with the Tor network, the short for the Onion router, but it's the main technology for evading a government firewall to access journalistic information or other information that they don't want you to see, and we're trying to integrate that into our standard human rights tool. So I think we end up thinking about security and privacy a great deal. On the reliability area, we do a lot of agile development. We do a lot of unit-based tests and regression testing so that a new version is going through essentially a great deal of automated testing so that we are aware, for example, if a new version introduces an unexpected bug, though, every year there's probably some bug that slips through that wasn't covered by our test coverage. So some quick responses on that one.
Thanks, Jim. So, Justina, your comments on security, privacy, and reliability related to your project?
Yes. I think, in my study, I kind of talked to quite a few teachers, and they feel that open source software are pretty secure in the sense that they are pretty much virus-free. Because, at school, a lot of students will just get online and just browse some website and download some, files. And sometimes if they use, proprietary operating systems, sometimes the computer may get virus very easily. So, that's one of the advantages of open source software, especially Linux-based operating system. In the case of reliability, I think sometimes the users may need to kind of, tweak the code, so they are not really very confident about this. So sometimes they still have some issue about the reliability. And I think one thing that quite a few teachers are concerned is about compatibility. I mean, sometimes open source software has its format standard, and when they try to pass the files to others, and if other people they don't know about open source software, sometimes they kind of have to look for information or ask the sender, what program can I open the file that you send me. So I think in the campus, I think teachers kind of concerned about compatibility a lot. Okay, and this is my quick response. Thank you.
Thank you. And Alex, your comments.
Yeah, so when dealing with patient records, it's pretty obvious that you have to make everything really secure. So fortunately for us, we were relying on a lot of physical security. We weren't dealing with any open access to the internet for our application, and so we didn't have to worry about people breaking in that way, but we also had to consider that people might come on site and take patient records away from the context that we were using to transport data from one machine to another. So in order to account for that, we have to encrypt the patient data on each device and also encrypt the drive on each device that we use. So really our hammer in this case was using encryption on all devices, including encrypting the context, so that even if somebody came on site physically and took some data away from us, they wouldn't be able to understand it without our encryption algorithms or decryption algorithms. So in terms of reliability, it's a long way to go on this application. There were a lot of things we didn't know until we could go over there and test it out. And so those will be accounted for in the next round, and those include things like, okay, we need to make sure that it's never going to fail in the case of producing a record, because if we see a patient, and say patient X gets a record that's standardized and then patient Y doesn't get one due to some bug, then we have a serious issue in our application. And since there's not a lot of technical support over there, we had to kind of feel it out and see what kind of errors we would be seeing, especially in our workflow. And in that regard, there's still a lot of work to be done, but we learned a lot from that last visit.
Great. Thanks, Alex. Are there any other questions for the panel?
I see a couple on there. One was on partnerships with mapping human rights issues, and I think the quick answer is that we often collect geolocated data, and we also work with a lot of different human rights groups that are collecting human rights sort of data that's on a geoframe. And so I think that's one of the more interesting areas in human rights. And I think the second question I saw that I think I got directly was about data connectivity. And a lot of the users we have of our human rights software and our environmental software are in low connectivity environments. And so even though maybe the state of the art today would be, or a few years ago would have been, do this all as a rich web application, the fact they don't have connectivity means that's not as good a design. So we end up dealing with, I think, stronger applications. We usually write in Java because it's pretty portable, so that the app actually can run on a machine that doesn't currently have internet connectivity, and then they're set up so that when internet connectivity is restored or is temporarily there, that they can essentially send their data to a server. So more of a client-server kind of application, which is not I think what most people will be doing, but for us, it turns out that we need to build these APIs so that we can deal with users who are actually working hard when they don't actually have connectivity.
Okay. Did you have any other questions come directly to you, Jim?
Open hardware products, I think I saw, and I know that there's a lot of exciting stuff in the open hardware area, Arduino and more. I don't know if other people have comments about open hardware.
Justina or Alex?
Yeah, I think there are some kind of collaboration with with some like hardware foundations such as Raspberry Pi. I mean, they provide open hardware so that we can connect to Scratch. It's also an like open source software that kids can do programming with. I think it is a kind of a very cool idea to combine open source like with open software with open hardware. I think I mean it is really very good because when you use when you try to kind of introduce open source software to the kids, I mean they can tweak the codes and do things with, and if you also introduce open hardware to them, I think they can do more. So I think it is I think open source software and hardware will definitely play a very important role in our future and in our kids' education. Okay, yeah.
Thanks. Alex, did you have any comments?
Succinctly put, I would say it's good. I think Justina covered it very well.
Okay. And Justina, did you have any comments sent to you privately, or any questions?
I don't see any questions sent to me. Yeah.
All right. How about you, Alex?
I'm seeing one from Don about the consequences of system outages. I don't think it's directly pointed at me, but I wouldn't mind fielding that one.
Sure, go ahead.
So in the case of our system, if we ever encountered a system outage, meaning one of our devices failed and therefore one of our stations failed, it was nice that we could just swap out that device with another one working. If we ran out of devices, then we could have one device serve as multiple stations. And while that may have created a bottleneck in our workflow, it would actually account for missing data, because the data is always stored on either a device or on a thumbstick. So if we lost, say, our main device, which held all the records, then we would also have all the records on these thumbsticks that we collect at the end, and we would be able to use those. But in terms of losing all the thumbsticks and the final drive that held all the things, we wouldn't have a paper trail. We would lose everything.
Okay. All right. I think we're just about ready to wrap up. I don't see any other comments in the general area. The last slide is up with the website to get information on future webinars and also find some of the past ones. For those who need the professional development hours, here's the code and the email address. And if you have any other questions, you can send it to the email at the very bottom of the slide. Again, I want to thank Jim and Justina and Alex for taking the time today to do this presentation. And for those of you who will be joining us in Seattle in a month, look forward to meeting you there. I think you'll find it a very worthwhile experience for those thinking about it. I think, again, it's a great conference, a great mix of people coming together. So again, thank you all very much. Thanks again to the staff folks for the great job in pulling all of this together. Thanks again for your time. Bye-bye.
Bye.